My speech today is a glimpse about the technological evolution in the steel industry. Can you see my screen? I have shared it. Can you see it?
Yes, we can see it now.
Okay, so my presentation today is about having technological aspects or technological evolution in steel industry. The contents of the presentation, we will go through the steel industry history, passing through the industry revolutions and the steel industry drivers. Then we will give an overview about the digital transformations in the steel industry, mentioning some of the steel making approaches, and then we will go through some examples for the modern approaches in the steel making process. As we may know, the industry has been through several types or several revolutions, starting from which we call it the first revolution, which started by the mechanization and generating the power from the steam and the water power. We called it Industry 1.0, and then the second revolution was related to the mass production and electricity, when the electricity has been invented. Then the third revolution was regarding the electronic and the using of IT systems and automation in the industry. Then the state of the art that all of the industries are now relied on, which is the fourth revolution, which is mainly related or based on the cyber physical systems and their use in the industry. As the World Steel Association mentioned some drivers that drive all with the industry, and they define 7 types of customer needs which always drives the industry towards achieving more. Such drivers are quality, transparency, customization, circular economy, and DFOTs, and flexibility, service orientation. All of those drivers are driving also the steel industry, but in the steel industry, the main focus, as all of us know about that, is the safety, which is always comes first, and the productivity and quality yield. So for the steel industry, the main drivers are safety, production, or productivity, and quality yield. For that, the role of digital transformation comes, and we need here to highlight about 2 main things, which slightly may be confused, or there is a slight semantic between each of them: the digital change and the digital transformation. For the digital change, the main characteristic of this type is it is the same version of the past, but it's in a better form, and it's vulnerable to disruption. However, the digital transformation, it shall include a new business model, not to be the same version of the past. It's a new business model, and it has new values. And for that, I'd like here to cite an example for the butterfly. And this is the transformation from the worm to butterfly. It's a transformation. It's not a change. It's the same type, but it's a transformation. So it's a new business model or a new shape of the same thing. For that, there are many digital transformation technologies. I think most of us are hearing about them in daily basis: augmented reality, mobility, blockchain, artificial intelligence, using of drones, data analytics, big data. All of such technologies are being used in digital transformation to change or to transform the industry. And the digital transformation, it is a journey. It's not related to a prepared box. It will be different from company to another, so it's specific to the industry and also to the company itself. Referring to the AIST digitalization resource, which is Digitalization 101, they defined mainly 11 types or 11 technology that the digital transformation is relying on, which are the IIoT or Industrial Internet of Things, simulation, system integration, machine learning or machine vision, autonomous robotics, big data, edge computing, cloud computing, additive manufacturing, augmented reality, and cybersecurity. Each word of this has many details and considered a science in itself. So we are here just highlighting such types of technologies, and we will go through our presentation to give some examples of each of them. As most of you know, that the steelmaking approaches has several types or several steelmaking have several approaches. If we will start by the iron ore and scrap, buffing through several types of process itself. So if we are talking about generating or making the steel from scrap, moving to the electric arc furnace, or using the fine ore or lump ore to generate billets, then to use also some blend with scrap in electric arc furnace, or another approach, which is to use lump ore and fine ore to generate billets, and then with pre-reduction to have the smelting reduction using the coal and oxygen, then to use the oxygen converter to produce the steel. And another approach is to use the lump ore with the coal to get the billets, and using the sintering to with the coke with the blast furnace to make the steel and generate the hot metal, then using the basic oxygen furnace or the oxygen converter to generate the steel. What we want to highlight here is regardless the approach that is using to produce steel, each of them nowadays is challenging and needs a lot of automation and high degree of control and accuracy level that needs more digital world and more powerful systems to be able to achieve all of this process in an accurate way and in an efficient way. So if we start by the supply chain for the iron ore or the oxide billet, each of them also nowadays related to automated systems like here if in the diagram in the left, you can see that the tracking for the material starting from the iron ore is defined by the RFID code, which is used to identify or trace the material wherever it is in the world till reaching to the scrap yards or the iron ore yards, and such material handling process are automated, or they are interfaced to another systems, which all together integrated to have the whole supply chain as a part of the whole digitalized systems. So it is not like before, like the normal steel industry, but it getting growing and getting improved through modern technologies and digitalized technologies. Another example here we highlighted it's the scrap classification, and for the scrap classification we have two examples. One of them from Danieli Corporation. They have invented a system to allow the operator to take a photo using a phone or any PDA, and then the photo the photos are transferred to a system or centralized system, which is used to characterize or classify the type of scraps based on an AI models, and using this they can build a 3D model to have an insights about the scrap bucket itself, which is its contents and its classifications, and by that it can be fed into another system like level 2 systems to get the details about the scrap bucket itself. Another approach here also for scrap classification is by SMS or Schlumann-Zimag group, and they are using the machine learning models to also to classify the different type of scraps. Here we can see different type of scraps here, which are different in the copper content, for example, and each of them will be fed into the electric arc furnace, and such information are fed into the automation system through this model or the machine learning model of SMS. Here, not only the steel making process or the scrap classification, but also if we get more inside the steel making process and talking about the DRI or direct reduction technology, as you know, the world nowadays are getting to be more green based on the Paris Agreement. Each of us wants more green world by reducing the carbon dioxide. So by that, there are a new initiative to take also the DR technology to be more green. And by that, they are depending on several approaches, green hydrogen or blue hydrogen or gray hydrogen. And all of them also needs a high level of automation and high level of technology to be implemented. So it's not like the traditional types of traditional approaches. It needs high level technology to be implemented. Here other examples for scrap preheating. If we also get more deeper inside the steel making process, so after the getting the ore and the DRI has been produced, if we are talking about the scrap classification, then the scrap needs to be preheated to be injected into the electric arc furnaces. So here, those are 4 types or 4 approaches for feeding the scrap preheated to the furnaces. Just for an example, the cone steel, eco arc, shark, and quantum, all of them are the main idea of all of them is to preheat the scrap before injecting it into the furnace, and each of them adopt several type of technology, but all of them can share the common concept behind, which is the demand for a high level of automation and high level of technology to be implemented. Otherwise, they might be just an idea. Another example for today's modern steel making process is to use the cyber physical production system, and by that, the famous automation pyramid or levels of automation pyramid or ARPA model that divides automation into 4 different levels of automation, starting by equipment control that contains the logic of controlling the equipment, the electrical equipment, motors, actuators, sensors, and instrumentation, and then to hand over the measurements to a higher level of automation, which is the process control and process optimization, which is called level 2. And then a higher level of automation is production management and control, which concerns with the quality management and work order execution, and a higher abstracted level for automation, which is the business management. Starting from the level 1 to level 4, nowadays, all of them depend on cyber physical systems. So it's not a traditional way of even for control and automation. All of them requires a high level of automation and high level of technology. By that, all of such automation systems nowadays depend also, some of them in another technology or another umbrella, which we call it artificial intelligence or AI umbrella. And by that, it's a huge umbrella, contains many or several types of technologies like the machine learning by its types, NLP or natural language processing, text-to-speech and speech-to-text, expert systems, planning, scheduling, and optimization using robots and vision. All of them are just some examples for using the artificial intelligence in the automation levels in the steel industry. For that, we highlighting some examples for intelligent data-driven systems for service quality. The first graph here represents the amount of data that are generated or are being generated from a hot strip mill. For that, you can see intelligent plant monitoring data and process automation control and MES production planning data, in addition to simulation and learning functions and online decisions. All of them have to be kept in data, and you can imagine the amount of data which we call here a big data, or it's a new idiom to be used, a big data. It's also existing in the steel industry, so it representing the huge amount of data that are required to be collected from the steel making plant. Here on the left, there is another example for the service inspection is presented by ISRA or Barstech company. They are using camera systems to getting the insight for the service and to classify such data to a certain defects, or to classify them to a predefined list of service defects holding scale or slivers or center buckles, edge waves, and so on. And for that, they are helping the operation engineers and process engineers to make their function in easy way. Another example here is to collect all of the data or data acquisition from level 2 and the other RDBMS or relational database management system to NoSQL database, and then to integrate all of those data to have more insights about the whole plant, to get or to define patterns related to inter-process, not a certain process, but inter-processes. So to determine maybe from the steel making process to have a certain parameter which will reflect on the final service quality or the final product. And here it's an example for AI application also for the front end bending, and this is for the from the Marcelo Sabarat, and he presented this case study in the AIST magazine, Iron and Steel Technology magazine. Another example is for the higher accuracy in measurements, and by that I'd like to highlight here for you two main examples. The first one is to use the laser scanner for the refractory lining, and here this is an example from Gregor Lamar from RHO Magnesita, who implement a machine learning system to maintain the refractory lifetime, and by that also they are depending on the laser scanner for measure the lining thickness and also to feed in the machine learning model. Another example is for the basic oxygen furnace, and for that they are using the laser scanner to visualize the status for the basic oxygen furnace from inside. And another example from EZDK, the company which I am working in right now, it's from the flat steel plant, and for that there is a system called mold monitoring system. It has been built by or commissioned by SMS Group, and for that this model depends on 100 thermocouple which are using to measure the thermal status for the mold in the thin slab caster to form a thermograph for the mold in the broad side and left and right sides. So you can have a thermograph for what is happening in terms of the thermal for the slab casting process. If we move to another driver for the steel industry, which is safety, here this graph representing the initiative for or the objective for the steel industry to achieve zero lost hours or safety hours. And by that, starting from 2006 to 2019, you can see that the slope or the cases are being reduced. And the main cause of this is using the automation in the steel plants more than before, which helped with a dramatic change in the injuries and safety issues in the steel plant. For that, definitely, it's a clear examples to mention here is the using robots in steel making processes, different steel making processes. And here you can see some example of that. For example, using robot for measurement inside the electric arc furnace, using robot for sampling, and also using robot for lining for the safe ladle sliding gate, and slag door cleaning, and many other applications that the robots are playing a very important role in achieving a more safe environment for the steel industry. Another example here is importance of the simulation in steel, and it's actually now the success of such initiative is due to the huge amount of or the power of using the server or processing elements right now. So by these very advanced systems, we can now implement simulation cases that was very difficult before, and maybe we can say they were impossible to have such simulation models. And by that, you can see here some models for the solidification, the bloom, till solidification, and fluid dynamics. And on the right, you can also see some kind of the simulation for the coil storage yard. So all of them is an application for using simulation in the steel industry. Such way saves a lot of time for trial and for experiencing with the team to achieve more without stopping the plant, and also to improve always the steel making process. Another example in terms of using the data analytics and big data in steel industry, one of them is using the augmented reality, which is to augment the reality with some data related to the either the previous experience or the documentation from the system, and by that you can achieve more experienced team even with less effort and less time, because they will be capable to see more data and to interact with the augmented reality. Another example here is this is an example for the CGL edge trimmer from a galvanized mill, and for that it's some type of remote training approach to allow the non-experienced team to interact and to experience on the process before getting them inside the workplace. Another example here from EZDK in Egypt, flat steel plant, and this is to use a QR code for tracing the samples for the ladle heating furnace and continuous casting plants. For that, the operator can just click a button from the level 2 HMIs, and the labels will be generated. He can stick these labels on the lollipop or the steel samples and send them to the lab. Lab can scan afterwards by scanners to get the data injected to the lab system, and by that the whole process is automated and flawless without any probability for wrong data entry or for missing steel samples. Another example here for R&D also. So even the R&D in steel industry is being improved and not like before. All of the R&D right now depends on using the cyber physical systems to enhance the R&D process to have more in-deep insights inside, even if we are talking about the grain growth in the reheating, starting from the as-cast structure from the caster, passing through the recrystallization and pancaking and the phase transformation in the cooling bed area. All of such processes are depends on the cyber physical systems to have a digital twin or to have simulated models to have more insights in them and to enhance the R&D process. Even if we are talking about the artificial or the art in steel, so here this is a famous example which is from the Dubai government. It is a famous model for the future museum. This model is so difficult, as the experts may know, because it has a very difficult curvature and a very huge amount of details in this shape. And to make it from steel, it was challenging. So they used 3D printing to build the model before executing, and also they used 3D printing for some of parts of the model. So this is also an example for using technology in the steel industry. So to conclude, what we are trying to mention or to explain in our presentation today is that the steel industry is evolving by the time. It's not fixed, as most of you may think that it's an old industry and an old science. It's always evolving, and it will evolve more by the time. And all steel industry processes are being improved by the power of the new technologies. The modern automation opens the door to apply many ideas in steel that were yesterday's dream. The digital transformation is driving the steel industry towards being more accurate, safe, efficient, and even dynamic industry. The digital transformation gives the steel industry a sustainable advantage, which in fact paves the path for greater success. And last but not least, the main thing that we want to conclude with is ignoring the change or wanting to be a follower mayn't allow your business to be maintained, join, or you may never catch up the train. Thanks a lot.
Thank you so much, Mohamed, for this presentation. You gave us a very good walkthrough, just a flavor about all the technology and different field application areas related to every single aspect of the production. Sometimes very small details involve or require a lot of technology and science involved. Thank you again.
I just want, as you know,
yes.
It's a big amount of information. I just tried to get them in one presentation. It wasn't so easy, but just I hope that it was easy to follow and to get the idea behind.
Yeah, it was, and thanks again. If anyone has any question, feel free to type it in the Q&A section. Just we have some comments. Thank you for your presentation. I think we do have a question. Oh, okay. We have one question for you, Mohamed. It's from Saul Centeno. And the question is, from your perspective, do you think that the basic knowledge of programming will be necessary for everyone involved in the steel industry in the future?
Yeah, it's a very important question. Actually, it was the main idea behind the presentation is to highlight the power of new automation and the new era of the steel industry. I think that programming is nowadays it's a basic need for anyone wants to achieve more and to find more insights in the daily activities and the daily process. So it's not a plus, it's a must. And by having a good skill in programming, you are open new challenges to yourself, new worlds, new insights for what you are doing. So to conclude, programming is not an additional skill, it's a mandatory skill, not only for communication or automation engineers, but also for operation engineers, process engineers, everyone in today's challenging industry is very recommended to know at least one programming language to enhance his capabilities to achieve more and more.
Thank you, Mohamed. Anyone has any other question, just feel free to type it. We can pass it away. Saul Centeno, thanks you for your answer and the excellent presentation.
Thank you, sir.